Hey everyone, welcome to this talk on Bicep Builders, Azure Sentinel, and Policy as Code as part of Azure Back to School. Azure Back to School is a yearly event hosted by Dwayne Netwick, bringing together community contributions covering topics relating to Microsoft Azure, Microsoft 365, and Power Platform. I'm Jesse Loudon, an Azure Policy as Code advocate.
And I'm Casey Mullineaux. I'm a cybersecurity engineer that focuses on Azure Sentinel and offensive security. So today, we're going to show you how to deploy Sentinel using Bicep to detect and respond to threats in your environment. Using Azure Policy at scale, we're going to apply governance to some key vaults that are configured with canary tokens, and then demonstrate how Sentinel can automatically respond to an attack in a live hacking demo. So stay tuned for that one. Now I'll hand over to Jesse, who's going to take you through our environment setup.
So before we continue on with Casey and showing the Azure Sentinel deployment with Bicep, I just want to cut over to a Key Vault resource that we have in our environment, just to show you some defaults out of the box with this type of resource. Now, Key Vaults are the natural repository for sensitive data like keys and secrets and certificates that are used by your infrastructure and your applications in Azure. So they are critical assets that need to be protected and secured. Now, out of the box, as you can see on my screen, these diagnostic settings are not configured. You do have logs that you can query and parse out of every Key Vault resource, but you would need to do that in this screen here per Key Vault resource. What we can do is take advantage of these diagnostic settings and actually configure streaming of audit events and metrics to a log analytics workspace. So if I just click logs and metrics here and I set a diagnostic setting name as such, and I can tick this box to send it to a log analytics workspace. There's one already deployed in our environment, and if I save that, that will then start streaming any of those logs and metrics to that workspace. So again, that's not configured by default, and what we're going to do is show you a bit later on how we do that with policy at scale, which will apply to any existing Key Vaults and new Key Vaults in the environment. Now I'm just going to hand over to Casey, and he's going to show you how to deploy Sentinel as code with Bicep.
Okay, so let's deploy Sentinel. First, I'm going to create a new file. I'm going to call that sentinel.bicep. So Azure Sentinel is comprised of two different Azure resources. There's a log analytics workspace, and then there's a solution for which you deploy inside that workspace. So let's configure those two resources. The first one is going to be my workspace. I'm going to give it a name called workspace, and the resource provider and type is Microsoft.operationalinsights/workspaces. I'm just going to use the latest version of the API, and I'm going to let VS Code tell me all of the required properties. Need to give this workspace a name. I'm going to call it Azure Back to School. It also needs a location. For this one, I'm going to use the same location where I'm deploying this resource, which is the location of the resource group. And this workspace also needs some properties. The first property it needs is a SKU, and that SKU needs a name, and I'm going to be using the per gigabyte 2018, and that's basically the pay-as-you-go model. Next, I need to define the retention for all of the data inside the workspace. I'm just going to set that to 60 days. Next, we need the Sentinel solution. So I'm going to create a new resource. I'm going to call that Sentinel. And this resource provider and type is the Microsoft.operationsmanagement/solutions. And again, I'm just going to pick the most recent API that's available. Now this resource needs a name. The name I'm going to use is Security Insights, and then the name of the workspace. So I'm going to use string interpolation to go into this workspace resource and get its name. So when we're deploying these two resources, there is an order of operations that must happen. the Sentinel solution has a dependency on the workspace existing. When I use the string interpolation here to reference the name of the workspace from the workspace resource, Bicep will automatically create an inherent dependency on that workspace. I don't need to worry about defining those dependencies manually. The next property I need to set is the location. And again, I'm going to use the location of the resource group. This resource also has some properties. If I hit Control Space on my keyboard, it's going to give me some IntelliSense. And the property I need to set is the workspace resource ID. As the name implies, this is the resource ID of the Log Analytics workspace. Because we're already deploying that workspace inside of this Bicep deployment, I can just use that resource to get its ID. Next, I need the plan. Hitting Control Space and using IntelliSense again, I can see all the properties that I need to set for this plan. So it needs a name. The name, again, is going to be the same as what I have for this resource. So I'm going to enter Security Insights. And the workspace.name. Next, the product. The product is OMS Gallery / Security Insights. For all workspace solutions, promotion code property is required. However, there's no promotion code available for Sentinel, so we can just give it an empty string. And the last property that we need is the publisher. And that's it. That's our Azure Sentinel deployment. So let's save this file, open up the terminal, and deploy it to Azure. First things first, let's create a new resource group. I'm going to call that Azure Back to School and give that a location of Australia East. Next, we deploy the Bicep file into that resource group. We do that by using AZ deployment group create -F and tell it where the Bicep file lives. And resource group we're going to deploy it into is Azure Back to School. If I come over into my portal, I can see my resources have deployed successfully. And if I open up Sentinel, I can see my Azure Back to School Sentinel deployment. This brings me into the Sentinel workspace. Azure Sentinel can help you detect and respond to potential threats within your environment. It does that by running queries against the logging data you ingest into the Sentinel workspace. For this demo, we're going to show you this capability through the lens of an Azure Key Vault using a canary token. A canary token is data that's planted somewhere within the environment that looks attractive to cyber criminals, but in reality, it's useless to them. Canary tokens get their name from when miners used canaries in the late 20th century to detect dangerously high levels of toxic gases deep within mine shafts. When a canary inhaled poisonous gases, its death alerted workers to dangers within the mine. Similarly, canaries in your network act as a warning system and sing out to administrators or security teams whenever they encounter a threat. The canary token we're going to configure will be a secret within a key vault that looks too attractive to pass over for a bad actor looking to gain a foothold within our environment. We'll then use Azure Sentinel to monitor the logs of the key vault and send notifications whenever that secret is accessed. Now I've already created a key vault, so let's go make that canary token. I'll come into the key vault, go to secrets, and I'll create a new secret. Now we need to give this secret a name that's going to be attractive to a bad guy. So how about our good old domain administrator credentials? Now this value doesn't really matter, it can be anything, and then we'll hit create. The next thing we need to do is enable logging on this key vault and send those logs to Azure Sentinel. We can do that by creating a new diagnostic setting. Hit add diagnostic setting. And we'll give this a name. Next, we want to pick the logs that we're going to send to Sentinel. We want the audit events, and we want to send that to a Log Analytics workspace. Select my subscription and my workspace, and then hit save. With that diagnostic setting now enabled, if we come back over to Sentinel and check out the data connectors, we'll see that there is one data connector connected. If I sort the status by connected, I can see that it has automatically enabled the Azure Key Vault connector. So the next thing that we need to do is generate some logs. To do that, I'm going to be using a offensive security tool called Microburst. Microburst is a tool that lets me query an Azure subscription, and it will try to dump as many credentials and secrets as it possibly can. This will connect to Cosmos DB, it will look for other database instances, it will look at storage account keys, and in our case, it's going to try and grab a whole bunch of Key Vault secrets. So before we can do any hacking work, there's a little bit of setup we need to do. That is, I'm going to need my black hoodie, and I'm going to need a green terminal. So I've already downloaded Microburst ahead of time. And all it really is, it's just one PowerShell module which groups together a bunch of custom PowerShell commandlets. I need to import that module. And the commandlet that I'm going to run is get AZ passwords. I need to give it my subscription. And then I'm just going to let that run. That's going to go off and enumerate my subscription and try and get any credential that it has access to. As we can see here, it's managed to dump a bunch of my credentials. I've got some keys for my storage accounts, and if I scroll up, I can see that it's got my canary token. I see here that it's a secret, the name of it is domain administrator, it's even dumped out the clear text value of what that secret is. Now that should have generated some logs in Sentinel. So let's go back into Sentinel now and take a look. If I click on logs, I can run a query against all the logs in the workspace that shows me the activity for that Key Vault. I want to search the Azure Diagnostic logs, where the resource provider is equal to Microsoft.keyvault. We're going to want to filter down to the get secret operation name. That's the specific event where someone is accessing the value of a secret. So I'll come up to my query and we'll add another where clause. Operation name is secret get. And if I run this, I've filtered down the events to just those ones where a secret was exposed. If we have a look at the details of one of these events, now if I scroll all the way down to the ID, what this is telling me is the name of the Key Vault, the name of the secret, and the version of the secret. So to make sure I don't get any false positive alerts on secrets that are not our canary token, I need to filter this query just a little bit more to scope it down to just this one secret. I'm going to do that by modifying the query, adding another where clause, and I want where my ID contains domain administrator. If I run this, if there are other key vaults and other keys, it means I'll no longer be returning those results. Now you can see why it's really important to enable logging on all of your resources. Without those logs, we can't run any detections like this. I showed you how to do it for one key vault manually, but what if you have hundreds? I'm going to hand you back over to Jesse so he can show you how to configure these diagnostic settings at scale using Azure Policy.
All right, so Casey has just walked us through the Azure Sentinel deployment, and now I'm going to take you through what you can do with Azure Policy in securing these key vaults and deploying the diagnostic settings at scale so that they're all onboarded to the Log Analytics workspace in your subscription. So here we've got over 100 key vaults we've deployed as part of this demo. Now I can go through, I can click ops to configure the diagnostic settings. I can use Azure CLI, PowerShell, ARM template. The real value that Azure Policy provides here as an alternative to those configuration options is that Policy can, once you actually apply it to your subscription level, for instance, it will apply to any new resources that are provisioned in the environment, and it can also do remediation at scale. So let me show you this. So I've deployed a policy already, and it's using a built-in definition for key vaults diagnostic settings. So I wanted to show you that there's kind of two methods you can go here. There's all these built-in policies that are available out of the box from Microsoft, and this particular one does exactly what we want for configuring the key vault diagnostic settings, and it's a deploy if not exist effect policy, which basically means it has a nested ARM template within the JSON to deploy the diagnostic settings. So this is some of the JSON here. So if I just ran that remediation for all those key vaults, it would work. But what if I wanted to change some of the settings within that policy? I actually couldn't do that because it's a built-in policy. So what I can do is I can actually bring that policy into Bicep and turn it into a custom policy and deploy that through my Bicep module. So let me show you my Bicep module to start off with. Going from the bottom actually. So I've got a definitions file where I'm going to bring in the custom definition for key vault diagnostics. That's linked to my initiative, and initiative is just, it's basically a grouping of common policies that you use to then assign to your environment. Another way to think of initiative is it's just a policy set. Now, those initiatives are linked to an assignment module, and the assignment is going to create the assignment at subscription scope for a demo, and it's also going to create a role assignment, which is important because when you have a policy which is deploying a resource such as, or configuring a resource such as diagnostic settings in this case, it's important for that policy assignment, which has a managed identity tied to it, that the managed identity is given the right access in the environment to make the change on the resource. And that's what this role assignment is. And then lastly, we've got a remediation resource here that we can kick off through the Bicep deployment to actually push out a remediation task to any non-compliant key vaults in our environment. So that's all done through code here. That's really an overview through the built-in Bicep visualizer, which is also available by just clicking on Open Visualizer on your main Bicep file. So if I take you through these files here, initiatives is containing, right now it's containing a built-in policy and a custom policy. So what I'm going to do is just comment out the built-in one, and I've got my custom policy there. It's passing in a log analytics ID as a value there for the parameter. And my custom policy here, which is using this JSON file, which I've actually just copied straight out of the portal. So this is the JSON file. I've modified a few things here, such as the policy type. I've changed that to custom, made sure the category in metadata was Azure Back to School. Some things here I've changed as well with the existence condition, which is basically when this policy deploys the diagnostic settings to a non-compliant key vault, this existence condition makes sure that that's what is expected. So it's checking a number of things here to basically report back to you as the administrator that the key vault is now compliant after the change. So I've changed a few of the equals values here. They used to be hard-coded true. I've changed it to use the parameter values for the metrics and audit events. And I've also done a change on the evaluation delay. So this is a new property, which is available for policy deployments, specifically for deploy if not exist effects or audit if not exist effects. And what you can do with evaluation delay here is you can change this to determine when your deployment for a non-compliant resource, such as a key vault, actually kicks off. Previously, it was set to 10 minutes. Now we have the option of changing this to after provisioning success. So if there's a new key vault being deployed, this will actually allow us to deploy these diagnostic settings through policy directly after that key vault is successfully provisioned, which could be 1-2 minutes, right? Rather than waiting 10 minutes. I think this is a lot of value. So I've added that in here in our custom policy. Now going back to my custom policy file, this is using a JSON load text content expression here. This is fairly new with Bicep. It's been brought in by one of the community contributors, And it's really useful because I can just reference my JSON file, load that into a variable called key Vault Diagnostics policy. And then as I create a new Bicep resource for my policy definition here, I don't need to hard code any of the JSON values that are coming from the policy definition. I basically just reference that variable and the properties of that variable there. So I think it's a very quick way of just creating custom policies and bringing them into sort of a Bicep implementation module here. Now, the other important thing, assignments. I mentioned before there's a role assignment here. And this is just taking the initiative ID and assigning it to our subscription scope. And it's using a system managed identity. There is also a user assigned managed identity that is possible for policy assignments. Now, I haven't tested that out yet, but I hopefully will in the future. This remediation task is something that can be triggered by you. It doesn't have to run every time you run the Bicep file. So I've actually got a deployment trigger on my main file for remediation. So here's my remediation module, which is bringing in that remediation file, remediation.bicep, within my folder. And there's an if statement here. So basically, it's looking at a parameter that I have in this file and saying if that's true, then run this entire remediation task and bring in a number of these parameters, such as the assignment ID and the remediation discovery mode. So the most important thing as well out of this entire module is the parameter file. So these are things that we can change and have them filter down to our deployment. So this is my remediation trigger. This is my log analytics ID, which is necessary for the diagnostic settings that we're configuring on the key vaults. And remediation discovery mode here is in this parameter file. Now, if I was to just run this, I can just copy this in here. Okay, that's running. So this is going to deploy my Bicep for Azure Policy as code. It will take a few minutes. In my parameter file, the remediation trigger is false. So it's not running remediation right now, but it has deployed my change. If I go back to the portal now and I refresh my initiative, just catching up here. Whoa. Okay, so this is my custom policy now that I brought in through Bicep. It's got a name there saying custom, so that kind of differentiates it from the built-in policy. And it is assigned as well to this subscription. And if I look at compliance of this policy, it's telling me that there are 101 non-compliant key vaults. So let's see. So what I can do with policy is I can trigger a remediation at scale of all the existing key vaults. Hopefully this loads in a second so I can just show you the overview. Yeah, here we go. So there's my one policy, the custom one in this assignment. And if I click into this custom policy, now I've got all these non-compliant key vault resources showing up in this list here. If I click on the compliance reason, it should show me that the, yeah, so it's saying the diagnostic settings are not matching what's expected in the policy definition. So let's trigger a remediation. So what I'll do is I'll change this trigger parameter to true, save my change. Not sure what that is. Let's ignore it. And then I'll run my Bicep deployment again. Yeah, so the advantage here is these existing key vaults can all be onboarded to my log analytics workspace at scale using the policy through this remediation task that I'm running now. If I also deploy a new key vault, it will also be onboarded automatically to the log analytics workspace because I have the policy assigned to the subscription scope, and it's going to automatically check that these diagnostic settings are configured. So if I just deploy a key vault here, say to this subscription, new key vault. Let's deploy this to Southeast standard short. Let's just create this. All right, so I've got a new key vault deploying, no diagnostic settings configured. Let's see how my remediation is running. That's going to take some time. It's a long running task because it needs to deploy across 100 or so resources. All right, so new key vault's been deployed through ClickOps. And I'll just show you there's no diagnostic settings configured. None there. If I wait a minute or so, I should see the diagnostic settings actually pop up, and they would have been deployed through policy as well, which we can see in the activity log. Okay, so what we'll do is we'll just take a quick break and come back once the remediation task has finished. And that remediation has now completed. It took about 30 minutes to fully remediate the 100 key vaults in our subscription configuring diagnostic settings. So if I look at this remediation task history, and I scroll down to one of these key vaults here, I can see the diagnostic settings are configured as per our policy definition. So we've got the log events and metric events now being streamed to our log analytics workspace, which is connected to Sentinel. This is done through the policy definition effect. And in the activity log of this resource, I've got an event here about the deploy if not exist action taking effect, which is part of the policy definition. So remember, that's the nested ARM template. So now this remediation took care of all existing resources. You remember I deployed a new resource as well, a key vault. And if I look at that key vault's diagnostic settings, that has the exact same configuration that I just showed you in the previous key vault. So it's now onboarded as well. I didn't deploy that diagnostic setting. It was done by the policy. Okay, so here's the events for that key vault that I deployed, which show the policy action taking effect to automatically set those diagnostic settings. Now that we've deployed these diagnostic settings to our key vaults, what we can do with the logs that are sitting in Log Analytics workspace is we can set up some analytic rules within Sentinel to actually pull out and parse specific events that we are most interested in relating to these key vaults. There's no playbooks or automation configured, so what I'll do is hand over to Casey, so he'll take you through the automation response part of these rules.
Thank you, Jesse. Now that all of the key vaults have had their diagnostic settings configured to send activity logs to the Sentinel workspace, we can create an analytic rule to detect and alert when our canary token is accessed. So picking up from the Sentinel deployment we created earlier, we can now modify this to add in our analytic rule. So create a new resource, and we'll call this canary token. And the resource provider and type is Microsoft.securityinsights/alert rules. And again, latest version. We can see here there's a couple different analytic rule types. They all do different things, but for the purpose of this demonstration, we're going to pick the scheduled rule type. A scheduled analytic rule will run on a defined schedule. It will execute a KQL query and then alert on any results. So for the scope of this rule, I need to define the workspace where I'm going to be deploying that into. Since we're deploying the workspace within this deployment, I can just reference that resource directly. And next, I need to give this a name and move on to the properties. Hitting Control Space, I can see that there are a lot of properties that we can define for an analytic rule. So let's fill these out as quick as we can. I need a display name. This is the name of the rule as it will appear in the portal. A description. This will also show in the portal and let others know what this rule does. And then we define the query. This is the query that we want to execute on that schedule. Whenever the query runs and returns a result, it will raise an alert. And the query that we want to use for this is the one that we defined earlier. So I'm just going to copy this straight from the portal and use a multi-line string to pop that in. And now I'll set some parameters around the execution of this query. I'm going to set the query period, which is when this query runs, how far back in my logs do I want to be searching to see whether an event has occurred. Now this value needs to be specified in the ISO 8601 time format. So I'm going to set P for period. It's a time period. It's not a time stamp. It's not a duration. It's a time period. And that time period is going to be 5 minutes. That means that this query is only going to be looking at the last 5 minutes worth of logs. So if the query period is 5 minutes, then the query frequency, how often I want to run this rule, is also going to be 5 minutes. So if I'm running it every 5 minutes, I'm only looking at the last 5 minutes worth of data, which means I can be notified really quickly whenever there is an access attempt to my canary token. A more realistic setting for the period and frequency in a real environment would be about 1 day. You want to run the scheduled rule once every day and look at the last 1 day's worth of data and then raise an alert or book an event. But obviously that completely depends on whatever the alert rule is designed to check for. High severity events, you might want to run more often. Next, I need to set the trigger operator. In this case, I'm going to select greater than, and for my trigger threshold, I'm going to put 0. What this means is when my query runs every 5 minutes, is going to look at the last 5 minutes worth of data, and if the results that that query returns is greater than 0, I'm going to raise an alert. And that brings us on to the severity. Getting VS Code to do all the heavy lifting, hit Control Space, and I can see all the values that are valid for this particular property. So I'm just going to select medium for the severity. And then I need to give it the suppression duration. The suppression duration is how long to wait when an alert is raised before a new event will raise a new alert. Again, using the ISO 8601 time format, I'm going to specify a good healthy value of 1 hour. This means it's going to run every 5 minutes, looking at the last 5 minutes of data. If a result is returned that is greater than 0, then raise an alert. And then when it runs again, do not raise more alerts until this duration has passed. But for this alert, I want that suppression to be disabled. And finally, the last property we need to set is whether this rule is deployed in an enabled or disabled state. And I want this to be enabled. So I'll save this, bring up my terminal, and run our deployment command to deploy this to the portal. Now if I hop back over to the portal and I click on analytics, discard that query, I can see that my analytic rule has been deployed. If I give that a click, I can see that it's a medium severity, it's enabled, it has my query that we put in, it's running every 5 minutes, it's looking at the last 5 minutes worth of data, and it's going to trigger an alert if the query returns more than 0 results. Now that we have our analytic rule creating alerts whenever the Key Vault Canary token is accessed, the final part of the process is to trigger some automation. For this, we use Sentinel playbooks. So I'm going to click over here on automation and then click on playbooks. Here we can see that we don't have any playbooks. I'll click create, blank playbook. And this is going to take me over to create a new logic app. Azure Sentinel playbooks are simply logic app workflows under the hood. We use them to define a series of steps that we want to execute during incident response. So I'm going to pick my resource group, give this logic app a name, make sure my region is set correctly, and hit review and create. That looks fine, and create. Now my logic app is deployed. I'll click on go to resource. And this drops me into the logic app designer. Now I'm just going to start off with a blank logic app. For a logic app to be available as a playbook in Azure Sentinel, it needs to use one of the 2 available Sentinel triggers. The first one in the list is the one that we use whenever we want our playbook to execute off an alert. And the second is the one that we want to use whenever we want our playbook to execute off the creation of an incident. Since this demo is dealing with alerts, I'm going to select the first trigger. To run this trigger, I need to authenticate into Sentinel. Since I'll be reading data out of my Sentinel workspace, I need to authenticate this playbook to give it access into my workspace. So I'll just do that very quickly. And now the playbook is authenticated. So here I define the steps that I want to be performed whenever that alert is raised. So what I'm going to do is I'm going to reach out to an API using the HTTP request action. And I'm going to want to select HTTP. And here I define all the parameters of this HTTP action. So what I'm going to do is change my method to get. And I'm going to enter a URL. And I'm going to hit the cat facts API and get a random cat fact. So I can show you what the API looks like just by hitting that URL in my browser. You can see that all this does is just return a random cat fact. So I'm going to need to be able to pass that. So I'll copy this to my clipboard, come back into the designer, and I'll add a new step. The step I want to use is pass JSON. That's under the data operations, and the action is pass JSON. Now there's 2 required properties here. One is the JSON payload itself, that's the content, and the other is the schema. It needs to know what parts of that JSON content is a string, what's an integer, what's an array, etc. So my content is going to be the output of my HTTP request. So I can use a dynamic value to get the response body. And for the schema, I can just click on this use sample payload to generate schema, paste in that payload, and that's going to generate that schema for me. For the next step in my workflow, I'm going to take that cat fact and I'm going to post it to Twitter. So I'll create a new step, type in Twitter, and I will use the post a tweet action. Now, as with any integration into a logic app, I need to authenticate to that service. And you do that through connections. I've already authenticated and created a connection to Twitter ahead of time, but if I wanted to add a new one, I can just give this connection a name, click sign in, and enter my credentials to authenticate this playbook to my Twitter account. So let's configure the tweet. I'll add a new parameter. I'm going to add my tweet text and enter the text that I want to tweet. Looking at the dynamic content of the past JSON action that came before it, I can quickly grab the value from the fact key that was returned from the JSON response in the cat fact API. That's it. Now I'll save the playbook. Now to deploy this playbook as code, it's as simple as exporting it from the portal as an ARM template, then decompiling that into a Bicep file and adding that to our deployment. So I'll come back to my playbook. I'll scroll down to export template and I will download that template. I'll open up the zip file And I'll grab that ARM template and I'll move that to the folder where I have my Bicep deployment. So we'll come back over to our VS Code and we can see that the template's shown up here. And this is just an ARM template like you would expect it to be. So what I'm going to do now is fire up the terminal. I'm going to run the AZ Bicep decompile command and specify my ARM template that I just exported from the portal. And when I run this, this is going to take that ARM template and turn it into a Bicep template. You can see that it's shown up here, and if I click on this, there's our deployment of our Canary token playbook defined in Bicep. So now I'm going to rename this template to give it a more appropriate name. And now I can hook that up to my Sentinel deployment. So down the bottom here, instead of defining or copying that Bicep template into this deployment template, I can reference that as a module. I do that by using the module keyword, give this module a name, and then specify the relative path of that playbook Bicep file. The only property that I need to give a module is a name. And that's it. I can save that file, open up my terminal, and redeploy. So with the playbook now deployed, we just need to hook that up to our analytic rule. So we'll jump back over to Sentinel and under the automation, and if I hit refresh, we can see our playbook. So coming back to analytics, I'll pick my analytic rule and I'll hit edit. On the automated response tab, I can now select my playbook. What this is saying is that every time that this analytic rule runs, it's going to execute this playbook, which we'll post on Twitter. We'll hit review, wait for the validation to pass, and we'll save. Now that everything's hooked up, let's generate some events. Now before we do that, because we have 100 key vaults and I don't really want to spam my Twitter feed, I'm going to come back over to my code and turn on my suppression. And making that change live is as simple as redeploying my template. Now we're ready to re-enter hacking mode. I've got my black hoodie on, I've got my green terminal. I'm going to rerun that same command I used before to dump all of the credentials out of key vaults. So I'll use get AZ passwords, specify my subscription, and let that do its thing. And as you can see, if we scroll up, we've dumped the credentials from every single one of our key vaults. We've made 100 canaries sing. If we now switch back to the Azure portal and we hit refresh, we can see all those events have now been generated. We can see here that one single alert has been raised, and that would have executed our playbook. So if we come over to Twitter and we have a look, we can see here that it's now sent a tweet about a cat fact.
Thanks for that demo, Casey. It's really good to know that we can respond to cyber threats at scale with cat facts.
Yeah, and that just really goes to show the flexibility of what you can achieve with Azure Sentinel and playbooks in an environment that's governed by Azure Policy.
Yeah, you know, I also feel the great thing about Azure Policy is that we can feel confident that our assets, both existing and new, are going to be compliant to our security standards, especially as we shift from ClickOps governance to an as-code methodology.
And that's going to wrap it up for today, guys. So we hope you enjoyed our session on Bicep Builders, Azure Sentinel, and Policy as Code. If you have any questions, feedback, or comments, please feel free to reach out to either Jesse or myself. Hope to see you again next time.